Okay, grade 12s, good afternoon. Hopefully everybody can hear me. I am actually going to get started right away because I'd like us to use as much of the 40-minute time limit that I'm allowed. If I don't get to finish all the questions that I had planned to get through, then I'll probably do it anyway. I'm probably going to post the questions that we're doing right now online and get you to try that on your own. And for everybody else who was not here anyway, that might be a good idea. But what I've done is I've pulled some questions from a question bank that cover the entire unit. And we're going to do them one at a time. You're hopefully going to be able to see them on the screen. And what I'm doing is sort of like when we have the clickers in class, when we're reviewing, which is that I'm going to ask you to put your answer in privately to me. And if I see everybody getting the answer right, I'm just going to move on. I'm not going to bother to discuss that question. If anybody gets it wrong, and I'm not going to name that person, obviously, I'm going to keep that anonymous, then I'm just going to go through the question, right? Once I see that there may be any difficulty with that question, I'm just going to do it with everybody, right? So that's the game plan, right? I have 28 multiple choice questions. So all you need to do is just put the answer in as A, B, C, or D for each one as we get to it. So let's start with the first one that's on the screen. Remember, please do it privately so that I can see your answer without anybody else seeing it, okay? All right, so I know everybody in the room, go ahead, put your answers in, and you can read the question for yourself. You really don't need me. The only time I'm gonna have to do any talking is if I see I need to discuss the question with you, okay? So go ahead and put your answers in for me, please. You can all see the question on the screen without me having to read it for you. This one, everybody got the correct answer, being D. So I'm gonna move on to the next question. Similar question, go. So I'm just gonna spend a little time on this just to make sure everybody's okay with it. They asked for opposite vectors. Now remember, opposite vectors are vectors that have the same magnitude and just simply run in the opposite direction. So the correct answer is C, and I'll show you why. So this is AB right here, running from A to B. Remember, that's the direction it's going in, starting at A, ending at B. The CD vector is this vector, which is the other side of this parallelogram, running from C to D. So it must be the same magnitude, and it's going to be just simply parallel to this vector up here, and that's why they're opposite vectors. So opposite vectors basically just have the same magnitude, but just the direction completely diametrically opposed, like a 180 from the first one, okay? All right, just thought I'd mention that. Let's get to the next question. Remember, if at any point I'm doing anything you wanted to get some more clarification on, just unmute, go for it, all right? Okay, there's your question, go. Okay, good stuff. I'm gonna move on, next question. Go ahead, please. Just so you know, I'm going to be pulling from this bank of questions when I'm putting the test together for Friday. So a lot of them are going to look very similar to these. So if you're getting through these, which is what I'm seeing right now, you're going to have no difficulty on the test whatsoever. Okay. I am going to go to the next question. Looks like we're going so quickly through this that we'll probably finish this way before the 40-minute time limit. Here comes, sure, yes, go ahead.
Can you actually explain number 4, please?
Sure. Okay, so vector D, we just move this aside here. Vector D is a vector running from where the two tails meet for A and B. So here is vector A, right? It's running from here to here. Here is vector B running from here to here. When we use a parallelogram law, and we have two vectors tail to tail, and we're trying to add them together, the resultant vector is always the diagonal from where the two tails meet to the opposite corner. which is exactly what D is. So that's why A plus B, which is what D is saying, this answer D that is this line vector D. A plus B is D. It's not C plus B, right? You know, that's not what this line here represents. This line here represents the diagonal of the parallelogram where two of the vectors that we're trying together meet, and they're tail to tail, and that's why it's A plus B. Does that make sense?
Yes, that makes sense.
Okay,
Thank you.
great. No problem. And thanks for the question. Okay, go, number 5. Okay, so let me talk a little bit about this. The zero vector, let me remind you, the zero vector is very much like 0, okay? If you add the zero vector to any other vector, it's like adding 0 to a number. So if you think of the number 10, let's just randomly choose a number. So you think of the number 10. If I add 0 to 10, what effect does that have on the original numbers? Well, actually none. You still end up with 10. And that's why the answer for that one would be C, preserves the non-zero vector. So the non-zero vector would be like the 10 I just talked about. You add the zero vector to that, you just simply get back the non-zero vector. It doesn't produce a zero vector, it doesn't change the direction, doesn't reduce the magnitude, it doesn't do any of these things. All it does is just simply keeps the original vector as it was, just like adding 0 to anything. All right, so that's why that answer is C. Okay, let's move on. There you go. And by the way, if you want to use the private chat to, raise something with me privately, that's fine as well. That's up to you. Or if you just want to do what I think it was Ashley who just asked the question out loud, I'm okay with that. Either way. Okay, so let me talk a little bit about this one as well. I want you to imagine. Let me give it to you this way. The answer, by the way, is A. The resultant is a zero vector, and I'm going to tell you why. Oh, okay, all right. So apparently everybody is now good to go. So I'm just going to move on. Next question. Okay, there you go. Now, notice that this question is asked for the velocity, because if I asked you for, oh, sorry, it should have said resultant speed, because I'm not asking really for velocity. Yeah, I should have changed this to speed, because I'm not, if velocity would imply that you have to give the direction as well, and that's not going to be possible for this answer. This answer is just simply different speeds. So give me the resultant speed, please. Think of that answer as being for speed. Go. Okay, I am going to call that one as being everybody got it right, so we're not going to spend any time on that one. Let's move on. Okay, go. What was the answer for number 8? Oh, we haven't done number 8 yet. We're doing it now. So you can put your answer in, Oyen. Oh, okay. Number 7 was A. I can go back and show the question again if you need to. But let's just finish this one first and then we can go back to that. So 7 was A. Just another couple of seconds and then we'll talk about this one. Yeah, we will need to talk about this question, but I'd like to see other answers come in and then I'm going to tell you what the answer is. Okay, so let me use my cursor and hopefully everybody can see it moving on the screen. It says AH. So here's A up in this top corner here. And I'm trying to get to H, which is in the bottom corner, like, you know, coming out of the screen down here. Vector A goes from here to here. Vector B goes along here. Vector C goes this way. So just so we understand the direction and where each vector is. This one goes up, this one goes to the right, this one comes out of the page this way. So if I'm trying to get from A to H, then I'm going to need to come along this vector here, and I'm going to have to come down, right? This vector here is my C vector. Remember, I'm starting at A. So I can, if I move along this line right here, that's the same as going along this line right here. That's my C vector. So I need to go along C, then I need to come down to get to H. No, coming down is the opposite direction to the A vector. So I'm going to take my C, positive C, I'm going to subtract my A, right? So positive C and subtract A, which would give you, in this case, for number 8, that would be B. So it's positive C minus A. If you're not sure about that, I can go with that again. But I'm trying to get from A to H. I need to go along this line, and I need to come down to get to H. I could do it this way. I could go down here and across here, but I'm still going to get the same result. It's minus A plus C. Okay? All right, next question. Number 9. Remember to put the number of the question before you put your answer, so I can just sort of keep track of which question you're answering. Okay, so most people got the answer, which is D, and a collinear vector, remember, is a vector which is running along the same line as the, or same direction, I should say, as the original vector. but it's either longer or shorter or going in the opposite direction. That's what makes it collinear. It can't be A because a parallel scalar is not even a vector. A scalar is just a number, right? Perpendicular wouldn't make sense. A scalar, again, is not going to result from multiplying a vector by a scalar. It's just a number. Scalar is not a vector at all. We multiply a scalar by a vector. It does change, not the direction of the, well, actually, it could change the direction because it could be a negative. It only changes the magnitude and sometimes the direction of the vector. So that's why it's a collinear vector. It's going to be along the same line, but it's going to be either longer, shorter, or going the opposite direction. Okay? All right, next question. Hopefully you can see that. Okay, I'm just going to move on. We don't need to talk about this question at all. All right, next question. Okay, so this comes down to the definition of a unit vector. The correct answer is, of course, D. And for some reason, when people did that online mid-unit quiz, there was a similar question to this that a lot of people, for some reason, that was the only one they got wrong. The definition of a unit vector is a vector which has a magnitude of 1, okay? So if A is a non-zero vector, so it's not a zero vector, if A is a non-zero vector, a unit vector in the same direction as A, the definition that we use to get the unit vector is to take the magnitude of A and divide it into A, or multiply by 1 over the magnitude of A, which is what D is. So 1 over the magnitude of, so let's just, let me give you an example. Let's say the vector was 10 units long. That's just going to make that up, right? So if I want to make that a vector which has a length or magnitude of 1, I'll just divide it by 10, right? I just take the magnitude divided by, if the vector was 15, then I divide it by 15 to make it into 1. Right? So in this case, we're going to take the magnitude of this, which is 1 over, sorry, which is what these lines mean, and then multiply the original vector by 1 over that. That's going to make that vector shrink down to a magnitude of 1. So that's really all it does. Okay? All right, I'm going to move on unless anybody wants me to talk about that some more. All right, but that's the definition. If you go back and look at when we were talking about unit vectors, this was actually the formula for a unit vector, right? What we're looking at here is the formula for unit vector. I don't remember what class that was that we did that. All right, next question. Go.
vaccination that's going to be injected into our system, or mRNA chips that will be implanted under our skin that will be placed inside of a vaccination that they will inject into our system. What I really find interesting is that people always talk about what the mark of the beast is, but very rarely have I ever heard anybody identify what exactly is this beast, because it is the mark of the beast.
Okay, so let me move, one second here. All right, so let me talk about this question a bit. They ask for the magnitude of minus 2a. No, magnitude is a distance. And I know that's the reason that some people put minus 6 there. But you can't have a negative distance. And that's why the answer is in fact D. So you did the right thing by multiplying by 2, because the magnitude of this one is 3. So what you're doing is you're making it longer. It is going in the opposite direction, but that doesn't affect the magnitude. The magnitude would just simply be a positive number. It's like an absolute value. You don't use negatives when you're talking magnitude. Okay? All right, next question. Let me minimize this back here. Okay, go. Okay, so let's talk about this. Remember that we have a right angle between these two vectors. So what that means is that essentially you could just simply use a rectangle to represent this question. And when we're adding two vectors together and finding their magnitude, remember that that would, in the case of a right angle, rectangle, it would just be the diagonal, which is basically Pythagoras' theorem, but they are scaled. So originally A was 5 and B was 4. We are scaling A by a factor of 3. B is not going to be scaled. So this side here is actually 15 units long. So take one side using Pythagoras again, using one side as being 5 times 3, 3 times longer than the original A, and using the other side as 4, find the diagonal in that rectangle. That answer works out to be 15.52. Let me just make sure 13 is B. Yeah, 15.52. So do that on your own. Just create a, you see, I think what some people forgot to do is to scale the A, and it is scaled, right? There's a scalar of 3. Scale it by 3, then add the B. Yes, it is going to be the diagonal because it's a right angle, but you have to scale that A first. All right? All right, let's move on. Next question. Hopefully everybody has their calculator nearby, by the way. And please remember to put your, or the number for the question beside the question. Just makes it a little easier for me. We're not going to get through all the questions, I can tell already. And like I said, I'm just going to post it online. And this time it's not going to email it to me. It will right away tell you how you did and tell you which ones are right, which ones are wrong. So I don't have to turn around and send an email back out to you, and then you can just keep retrying it until you get the right answer. So that's the way I'm going to do it this time, right, when I post this one. But we'll take this up to the 40-minute limit at any rate. So keep going. Number 14. We talked about that business of unit vectors a few minutes ago. So the formula that we had then should hopefully apply now. Okay, so let me talk about this a bit. I just want to remind you that the formula for a unit vector is 1 over the magnitude of the vector, right, multiplied by the vector itself. So in this case, you are supposed to use the actual angle between them, which is the 60 degrees, because you're minusing. If this was that you were adding them together, then you would use a supplement of the angle, but we're not using the supplement because this is the difference between the two vectors. So we're actually going to use 60. So the cosine law would have given us, I think it was 63 as the square root of 63 as the magnitude. So we would have to take 1 over that magnitude and then multiply it by the difference of the same vector. So it's multiplied by the same a minus b, but with this scalar to bring it to a unit vector magnitude. Okay, so that's why that answer is that one. Okay, let's move on. Already got the 30-minute warning in terms of time, by the way, so we only have about 10 minutes left, but we'll do what we can. Let's keep going. Number 15.
Excuse me, Mr. Cannon.
Sure.
I just had a quick question about the test itself.
Yes.
Will it be around 20 questions as well, just like this?
Well, this is actually 28. I haven't really, it's probably going to be a 45-minute time limit like the last one. And I'm thinking it's probably going to be something like the online one that I did where you'd have some multiple choice and then you'd have to actually do some calculations and enter the answer. So that's what I'm thinking right now. I mean, it's a week away, so I haven't actually come up with the test yet, but I am saying that the questions that we're doing now would be likely the same kinds of questions that we're going to be doing on the test. Okay?
Okay, thank you.
You're welcome. All right, so we're on number 15 now. Let's see what you got. Okay. So, quick, let me see now. Okay, yes, I need to talk about this for a bit here. So this 3/5 of A is not changing the direction of A at all, right? Because if you were changing the direction, it would have been a negative in front of it or something else. All the scalar is doing is changing the magnitude of A. Now, A used to be 50 kilometers per hour northeast. It's still going to be northeast. So we can immediately take out the southeast and the southwest. All of these are out. And in fact, you could have answered this question by just simply thinking about the fact that the vector is not changing direction. It's still northeast. But to go further, 3/5 of 50 is in fact 30, which is why that answer is 30, D rather. Okay? All right, next question. Oh, this one you should just simply put a quick answer in so we can move on. This is one of the things that was just simply a property of vectors. You just need to know what the name is. So give me an answer so that we can put this to bed and move on quickly, please. Okay, in the interest of time, everybody got it right. So I'm gonna move on. All right, number 17. All right, let's see what you do with this one. There was something similar to this on the quiz. Let's see what you do with that one. Determine the coordinates of C. Okay, again, in the interest of time, I'm gonna move on. Everybody who answered it right. Okay, now this one is a little different from stuff that we've done, but let me just sort of, outline it for you. This prism, so this rectangular prism is bisected by the XY plane. Here's my XY plane. It runs right through the center of this prism. So using that information, the point P, which is this point up here, is 373. What's F? Let me get at least one more answer in for number 18, and then we'll see what we'll do. Okay, good. I'm going to talk about it anyway. So here's a point P. There's the 373. That's what the coordinates of this point are. The components of this point are. The only way I had to move from P to get down to F is I went down. So I'm moving down the Z axis, which is the third coordinate. So if I was up here at +3, and this was split exactly in half, I'm going to go past the XY plane onto the negative side of the Z axis, which means that I'm going to go from +3 down to -3, but only on the Z axis. So my 3 and my 7 don't change. I'm still 3 along the X right here, at F. I'm still going to be at the same, 7 along the Y, but I'm going to be coming down on the Z axis by, well, actually 6 in all, because I went from 3 to 0, then down to -3. So that means that my 3 and my 7 are both good, but my Z value goes to -3, which is why the answer is B. Okay? All right, let me move on. I'm going to mute myself while this phone here rings. Okay, nice work. We have about 2 minutes left. Let's see if we can get at least 2 more in the time that we have left. Okay. Well, the answer is actually C, Z equals -3, just so you know, because we went all the way down here to get to the DCFG line. Okay. All right, let's move on. Hopefully you can see that question reasonably well. I did try to tidy it up. What's the length of the diagonal? There is OA, there is OB. Go for it. And this probably is going to be the last one that we're going to do. Sorry. I'll post it, like I said, online, and I'll provide a link on the Math Video Library. And you can always email me about any questions that you're not sure of when you're trying it out, but it will tell you right away which ones you got right, which ones you got wrong.